So for function notation is another way to represent a y equals to an equation. We're going to look at these two setups where y is equal to 3x plus 2 versus f of x is equal to 3x plus 2. We know that this is a linear line with a slope of 3 and a y-intercept of 2. And we know that if we use a table of values and plug in some values, we can plug in -1 here. 3 times -1 is -3 plus 2, so then you're going to get -1. When I plug in 0, I'm going to get 3 times 0 plus 2, so I'm going to get 0 plus 2, which is going to give me 2. If I plug in 1, 3 times 1 is 3, 3 plus 2 is then 5. The same idea happens for function notation. The only thing that's different is really and truly the notation. Your x is still your x coordinate, your y is still your y coordinate, and we just represent it now with f of x. Now this is read as f of x, which is meaning the function in terms of x. So if x was -1, we would then say f of -1 is equal to, and we would replace wherever we see an x with -1. So it's doing the same thing as plugging it in. The only difference now is that our notation, when I work through it, I can now see my x input and my y output. If I plug in 0, f of 0, so again I replace wherever you see an x with 0, and then I will have my f of 0 is equal to 3 times 0 plus 2, f of 0 is equal to 2. So my table of value looks identical. The only difference is I'm writing it with this new notation. The new notation lets you have an x input and a y. So you can see both things in terms of x and y. So now, in terms of graphing, we can see that at -1, I will have a point at -1, -1. I will have a point at 0 and 2, and I will have a point at 1 and 5. So when I graph it, I will get the same thing for both cases. Coordinate points don't change. 1, 2, there's a point there, and at 1, 1, 2, 3, 4, 5, right there. So the graphs look identical, and you can see quite easily that everything translates exactly the same thing. The only difference now is the actual notation. So if they give you an example where they give you 2 points in function notation and they tell you it's a linear function, you have to actually now take this information, translate it into an equation. So by telling you f of 2 is equal to 3, we now know that that coordinate point is 2, 3. X is your input, y is your output. And if they give you f of 4 is equal to 9, that also tells me a point at 4, 9 for the same idea. From this, I have 2 points on the function and I know it's linear, so then you can use your slope, y2 minus your y1 all over x2 minus your x1. Your slope is then equal to then 9 minus 3 all over 4 minus 2. So we get 6 over 2, so my m is going to be 3. Now it's a linear function, I now have a slope for that linear function. And we have 2 possible points. So you can now use our slope-intercept format to figure out what the equation of the line is going to be in. So y minus, and let's say I choose the first point, y minus 3 is equal to 3x minus 2. Now if you wish to use the other point, you can do that as well. From this point here, if they asked you to put the line in standard format or slope-intercept format, you can do that as well. If they don't specify, well, you're done at that point here. Now some other examples are where they give you an x input, or they give you a y value, or they plug in an algebraic expression. So for these types of problems, we're going to be giving the definition of what the function is. F of x equals 4x minus 1. So f of 3 means that our x value is equal to 3. So wherever we see an x in the equation, we can replace it with 3. So 4 times 3 minus 1. And then as we go along, f of 3 now equals 12 minus 1. So then f of 3 is equal to 11. There's our final statement. It shows us what our x input is at 3, and it shows us our y output at 11, which also corresponds to a coordinate of 3, 11. Now when f of x is equal to 19, this technically means that y is equal to 19. So we can replace f of x with what the function is. So 4x minus 1 is equal to 19. To both sides we can add 1. 4x equal to 20. Divided both sides by 4. X is then equal to 5. Now in function notation we can write that as f of 5 is equal to 19. Again, we have our x input and our y output all in one statement, so we can see everything that we're working with. Another scenario is when you have an equation, an expression I should say, that is being plugged into the function notation. So f of 2a plus 1 is equal to 4 times, and again we replace whatever is an x with 2a plus 1 minus 1. So f of 2a plus 1 is equal to, and if we distribute, we get 8a plus 4 minus 1. And again, if we simplify this out, we get 8a plus 3. That's then your function notation in terms of an expression being plugged in terms of a.